This video is going to talk about two-way frequency tables and doing probabilities with two-way frequency tables, Venn diagrams, and tree diagrams. We've already discussed those in Math 1, but what we're going to do in the Math 2 portion of this is now add in probability using those diagrams and tables. So here's a couple pieces of information about a two-way frequency table. It does deal with categorical data, so information that I can sort into different types of categories. For example, hair color, what kind of animal you prefer, if you're a dog fan or a cat fan, if you prefer to go to the beach or you prefer to go to the mountains. Those are categorical pieces of data that we can use. The first word problem we're going to do for a two-way table is men and women and dealing with different types of music that they like. Now, I did do the guided notes on the Math 2 page underneath the probability folder. Please feel free to print those out and use those. So I have already created my table and I filled in my headings for the gender of the person that was interviewed, as well as the type of music that they preferred. And what I'm going to do is start taking this word problem apart piece by piece and figuring out where each of those data totals they gave us, where they belong in the table. Right off the bat, 100 adults are surveyed. That tells me that the absolute total of my table is 100. So of the 52 men surveyed, 12 chose jazz, 19 chose classical, and 4 chose folk. Now all of that information is in some way, shape, or form going to go in the men row because I'm talking about men. So because it says that of the 52 men surveyed, that tells me that that is the total amount of men that have been questioned. So that would be 52 under the men total cell. 12 of these men chose jazz, 19 of them chose classical, and 4 chose folk. At this point in time, you could stop and figure out the cell for men rock. I'm going to keep piecing the puzzle together with what's in my word problem and save filling in the empty spaces for the end. So the next thing that they tell me is that 23 of the women chose rock. So I'm going to look for the women and rock cell and where those overlap, and that's where 23 is going to go. Overall, there's 23 that enjoyed jazz, so that would be my jazz total. And then 11 that chose folk, so that's the folk total. They did give me the information about what probability question they're asking me, but because I don't have a complete table, I'm not going to piece this or take this apart until I have this filled in. Now, in order to get these empty spaces, I'm going to put these in a different color so you can see what pieces I went in and had to calculate. Ultimately, every column has to add up to the total, and every row has to add up to the total. The total row needs to add up to 100 as well as the total column. And so I'm going to use my addition and subtraction and kind of manipulate the table to work for me. So I know I can fill this in. There's 9 people that were women that liked jazz. Can't really do anything here yet, so I'm going to keep going. This would tell me that there's 7 women that liked folk. And if you come along here, I can't do anything else in this column, but I could figure out 48 women total because 100 minus 52. Now I'm going to work out rows and see what else I can find out. To find the men that liked rock, add these 3 up together, subtract it from 52. That's going to give me 17. I could do the same thing to figure out the women that like classical, which ended up being 9. Now you can add straight down. This is going to give us 40 and 28. So, probability of selecting a woman or an adult that did not choose classical music. If you think back to the exclusive and inclusive conversation we had the other day, because I am only selecting one person out of the crowd, I have to think of if these are separate events or if they overlap at all. So could a woman have also not chosen classical music? And the answer is absolutely. So what I'm going to do is I'm going to look at it as one statement and see if I can pick the pieces out of the table that would help me figure out the women and the people that did not choose classical music. I'm going to see if where they overlap and try to take those out. So I definitely know that there were 48 women altogether that were surveyed, which does also cover women that did not choose classical music. So I'm not going to include any other pieces from here because I would be double counting them. And I'm not going to use my totals down here because, again, that would double count these women that didn't choose classical. But what I do need to include is the men that did not choose classical. So I need these 12 people that chose jazz, these 4 men that chose folk, and these 17 that chose rock. And what you can do now is I'm going to combine these people all together and try to make a probability fraction out of that. So my numerator is going to be all of these people that I have squared in green, which is going to give me 81 people total. And the denominator, because I'm looking at all of the people that were surveyed, would be 100. Now you can simplify this, that's totally fine. I'm going to leave it as 81 out of 100 for now so that we can see where these numbers came from. So that takes care of two-way tables. Now we're going to step into Venn diagrams. So Venn diagrams you have seen before. These are the ones with overlapping circles, and we're going to look at 2 examples together on this. So the first example, a class of 60 students, 21 of them are signing up for chorus, 29 are signing up for band, and 5 are signing up for both. 15 of the students in the class are not signed up for either class, band or chorus. So I'm going to make a scenario out of or a Venn diagram out of this. Because there could potentially be some students, 15 in this case, that did not take either class, I'm going to represent all 60 students in a rectangle and then put my band students and my chorus students in the circles. So this is going to be the band kids, and this is going to be the chorus kids. And ultimately, everything inside of this box should add up to 60 students total. So I already know that there's 15 that didn't sign up for either class. And because they didn't sign up for either, they have to be outside of these 2 circles. But they still have to be included because those are part of my 60 students. 21 signed up for chorus, 29 signed up for band, and 5 signed up for both. So the ones that sign up for both are going to go in the center where they overlap, because there are 5 students that do go to both courses. Now the problem is, if 21 students have signed up for chorus, these 5 students are part of the chorus circle, and they're part of that 21. So in order for me to figure out how many of these students are just taking chorus, I need to subtract those 5 students, and that would tell me that there are 24 students that are only taking chorus. And similarly, I'm going to do the same thing with band, which would tell me there's 16 students that are only taking band. So if you add these all up together, 15, 16, 5, and 24 should get you back to 60. So the probability that we're looking for is the probability that a student is only taking band. Well, the kids that are only taking band live in this part of the band circle, so that's 16 students out of the 60 students that are in this class. The next one is dealing with allergies. Now because this problem, if you read through, it doesn't talk to us about anybody that is not allergic to anything. So I'm just gonna double check really quick and make sure that I can get myself to those 21 students and that I don't have any left over that are not allergic to either one. So if I add up 14 and 12, so the 14 that are allergic to peanuts and the 12 that are allergic to shellfish, I've got a problem. Because that gives me 28 students altogether. I'm sorry. There's 14 students that are allergic. It helps if I read the problem all the way through. There are 14 students that are allergic to peanuts and 12 students that are allergic to shellfish, which is going to give me a total of 26 students. There's a problem here though, because 26 is more than what they gave me as the students that have these allergies. So this tells me that I've got some that are in that both category that I counted twice. So in order to get me back down to 21, that tells me there are 5 students that are allergic to both, because there's a difference of 5. So now if I make my Venn diagram, I'm going to do peanuts and shellfish, and those people in the both category are going to go in the middle. So, just like we did on the last problem, in order to find the number of people that are only allergic to peanuts, I'm going to subtract, which is going to give me 9. I'm going to do the same thing to figure out the number of students that are allergic to shellfish, which is going to give me 7. And now our mission is to find the probability that a student is allergic to both peanuts and shellfish, which are those people that are in the overlapping section because they have both a peanut allergy and a shellfish allergy. So that would be 5 out of 21. And the last thing that we need to talk about is tree diagrams. Tree diagrams are going to deal with a sequence of things happening. And I'm going to skip to the problem about the goalie. So we're going to go off to soccer. We want to be the goalkeeper, but it depends on who's coach that day. So we could have Coach Sam, and the probability of being goalie with Coach Sam is 0.5. With Coach Alex, we have a possible goalkeeper probability of 0.3. So I'm going to stop there and I'm going to start building my tree diagram so that we can see what's going on. So right off the bat, I could be with one of 2 coaches. I could be with Coach Sam, or I could be with Coach Alex. And depending on which coach we have, I could be goalie, or maybe not. Same thing with Coach Alex. I might be goalie, I might not. We don't know. Now just so everybody knows what's going on, each of these that I've put down is an outcome. These are called your branches. And on each of my branches, what I'm going to do is label the probability that one of these 2 things has happened. Anytime I branch out, whether it be 2 branches, 3 branches, 5 branches, the total probability or the total possible outcome percentage can never be more than 100% or a decimal probability that adds up to 1. So this couldn't be 0.5 and 0.9 because that would put me over 1. And we know there's only a 100% chance of anything happening or not happening. So I'm going to go through again my problem and see if I can start filling in some pieces of information, some probability on the branches. So with Coach Sam, we have a probability of being goalie of 0.5. So on my Sam goalie branch, I'm going to put 0.5 because that's my probability with Coach Sam. And with Coach Alex, I have a probability of being goalie that is 0.3. Coach Sam is coach more often. About 6 out of every 10 games, So a probability of 0.6, and our goal is to find the probability that we're going to be goalkeeper that day. So I have some missing probabilities that I need in order to completely get to my probability answer. So if the probability of Sam being coach is 0.6 or 60%, that tells me there's a 40% chance, or 0.4, of Alex being coach. I'm going to do the same thing here with goalie and not goalie in order to make this add up to 1. That would be a 0.5 or 50% chance. Here, this would be 70% or 0.7 that we are not going to be goalie. All right, so how am I going to figure out the probability in this case? Well, the probability of us being goalie, me being goalie shows up twice on my chart. Could be the goalie with Coach Sam, or I could be the goalie with Coach Alex. So I need to know these two possibilities. I need to know the probability of each of these happening, and then I'm going to combine them to figure out the total possibility or the total probability of us being the goalie. Now, in order to figure out the probability that I am goalie with Coach Sam, what I need to do is think, okay, probability of me being goalie depends on who is the coach. So because there is a dependence there, that tells me I have multiplication that I need to deal with. So 0.6 multiplied by 0.5 gives me 0.3, or 30%. So there's a 30% chance that Coach Sam is going to be the coach and I'm going to be goalie. Same thing with Coach Alex. I've got 0.4, so 40% chance of Alex being the coach, 30% chance of me being the goalie with Coach Alex, which is going to give me 0.12. Now, because I could be goalie with Coach Sam or I could be goalie with Coach Alex, this is a one or the other, which means now I've got some addition I need to complete. And that's going to tell me I have a 42% chance of being goalie depending on who is coach that day. So that's the end of the diagrams and tables video. Make sure that you have these notes prepared for class Monday. If you have any questions, shoot me an email, let me know. Otherwise, enjoy your weekend.